Hello, everyone. My name is Edward Gao, and I welcome you to today's presentation on understanding and preventing SQL injection. This topic is extremely important in our modern digital world. I'll be sharing insights that can help correct and protect our data and our systems. In the next 15 minutes, I will be exploring what SQL injection is and why it matters. I'll also discuss real-world example and illustrated in its impact. My goal is to equip you with practical knowledge to recognize and prevent these attacks. You will hear about various types of SQL injection and the best practices to combat them. Please feel free to take notes as we progress through the slides. I hope you find this presentation both informative as well as engaging. Let's begin our journey into understanding SQL injection. SQL injection is a critical security vulnerability in web applications. It occurs when attacks inject malicious SQL code into input fields. This injected code is then executed by backend database. The consequences are unauthorized access or manipulation of data. For example, an attacker might insert a rogue SQL statement that bypasses login credentials. Such an attack can compromise entire databases in just few minutes. I will provide examples that illustrate how simple inputs can lead to um, severe breaches. The technique exploits weaknesses in user input validation. It is a favorite method among hackers due to its effectiveness. Today, we will examine both the mechanics and the prevention strategies for SQL injection. Now we'll talk about the importance of studying SQL injection. Studying SQL injection is vital because it represents one of the most common attack vectors in cybersecurity. Many data breaches have been attributed to vulnerabilities in SQL queries. Understanding this issue helps us design more secure applications for businesses and successful SQL injection attack can lead to severe financial losses. It also compromises computers' trust and can damage a company's reputation um, severely. In educational setting, in educational settings, learning about SQL injections prepares us in future developers for real-world challenges. I will share examples where companies suffered massive breaches due to SQL injections. And by studying these cases, we can learn about the preventative measures and methods, and this knowledge empowers us to secure our data effectively. Ultimately, understanding SQL injection is a key component of comprehensive cybersecurity strategy. And now we'll talk about the key terms of that involves SQL injections. Before we dive deeper, um, let's just let us look at some essential terms. SQL or structured query language is the language that we use to manage databases. Code injection is the process where attackers insert harmful code into a system. A vulnerability is a weakness that can be exploited by an attacker. I also want to mention um, parameterize, uh, para, parameterization is a method to secure SQL queries. Input validation is the process of ensuring user inputs meet expected formats. These terms form the foundation of our discussion today. Understanding them is crucial for grasping the mechanics of SQL injection. I will refer back to these definitions as we progress. Each term helps us understand both the problem and the solutions. These fundamentals are the building blocks for secure coding, coding practices. Recognizing SQL injection. Recognizing SQL injection vulnerabilities begin with understanding how how users' inputs are handled. Usually, errors in the database can be early signs of an injection attempt. So, for example, unexpected error message in your web application may signal that SQL coding is being executed improperly. I have seen cases where a simple login form was exploited due to poor input validation. In addition, abnormal database responses or delays in performance can indicate malicious activities. Attackers might exploit fields that accept text input without proper sanitization. These are red flags that every developer and security analyst should be definitely be aware of. Recognizing these symptoms early can help prevent a full-blown attack. I will show examples later on how these signs manifest in real systems. Early detection is the key to effective protection. And the types of SQL injection attacks. So we have in-band SQL injection, inferential SQL injection, and out-of-band SQL injection. SQL injection attacks can be categorized into these three main types. The first type is in-band, which attackers use the same channel to send the injection and receive results. The second one is inferential SQL injection. Uh, is also known as blind SQL injection, where attackers deduce information from the system indirectly. The third type is out of band, which relies on different communication channels for injection and data retrieval. Each type has unique characteristics and challenges for defenders. For example, in-band attacks are typically easier to detect due to the nature of immediate responses. Um, on the other hand, inferential, aka blind SQL injection, require the attacker to infer data by analyzing the system's behavior. And lastly, out-of-band SQL injection um, attacks are more rare, but can be practically also very stealthy. I will provide examples of each type to clarify their differences. Understanding these types is essential for developing tailored security measures. This classification helps in choosing the right prevention and detection tools. So let's talk about in-band SQL injection. In-band SQL injection is the most common and direct method used by attackers. In this approach, the attackers injected the code, and the result of that code travels through the same communication channel. For example, consider a login from where the input is not properly sanitized. An attacker might type in a statement like or 1 equals 1, where it forces the database to return all records. This technique exploits the application's trust in users' input. As a result, unauthorized users can bypass authentication entirely. I have witnessed scenarios where even a minor flaw in coding leads to a full system compromise. The immediacy of the response make in-band attacks easier to execute. Because of this simplicity, the method remains pre prevalent in many attacks. The direct feedbacks help attackers refine their tactics in real time. And the next type will be inferential, aka blind SQL injection. Uh, Inferential SQL injection operates differently from in-band attacks. For this type of SQL injection, the attacker does not receive a direct output from the injected query. Instead, they observe the behavior of the application to infer data. For instance, the attacker might input a query that results in a delay if a condition is true. A time-based response can reveal whether a particular piece of information exists in the database. I recall a case where an attacker used response timing to deduce the existence of administrator accounts. Although the method is more labor sensitive, it can be just as damaging as inbound attacks. It requires a deeper understanding of the application's behavior and careful analysis of the responses. The the subtle nature of um, inferential SQL injection often makes it very hard to detect. The technique highlights the importance of proper error handling and secure coding practices. And lastly would be the out of band SQL injection. Out-of-band SQL injection is a less common but highly effective method under certain conditions. This attack vector leverages the database server's ability to make external HTTP or DNS requests. For example, an attacker might insert code that causes a database to send data to a server that they control. This method is particularly useful when the attacker cannot see the output of their injection directly. I have studied cases where out-of-band techniques were used to ex, exfiltrate, exfiltrate sensitive data without triggering standard alerts. Such attacks often rely on unique configurations or specific data features. While being less common, the stealthy nature of this approach makes it very hard to detect and dangerous. It bypasses conventional monitoring methods that only look at direct outputs. The use of separate channels for attacks and data retrieval complicates the detection efforts. This underscores the need for comprehensive security strategies that covers all possible vectors. Now let's look at some real life example of SQL injection. One well-known incident occurred in 2014 at Sony Pictures, where attackers used SQL injection to access sensitive data. This breach resulted in confidential information being leaked and significant financial losses. Another example would be the Heartland payment system breach, where SQL injection was a critical factor in stealing millions of credit card details. In both of these cases, poor input validation was a major contributing factor. These examples illustrate the catastrophic impact that a single vulnerability can have on an organization. They also highlight the importance of continuous security testing. I have seen firsthand of how ignoring these vulnerabilities can lead to such devastating consequences. Real-world cases remind us that prevention is always better than cure. And by learning from these incidents, we can design a much better secure system. Now let's look at the impact of SQL injection attacks. First, they can result in severe data breaches where personal and sensitive information is compromised. For businesses, this can mean substantial financial losses due to impact on customer trust and the brand reputation in general. I have witnessed organizations struggle to recover after a major SQL injection incident. In some cases, legal actions and regulatory fines have compounded and add on the damage. The attack can also disrupt normal business operations, leading to downtime and additional recovery costs. In addition, the public exposure of such vulnerabilities can deter future customers. These impacts underscore the need for rigorous security measures, and ultimately, the high cost of SQL injection attack makes prevention a very important priority. And let's look at how to prevent SQL injections. Some of the best practices and the importance of improvisation. So preventing SQL injection starts with the adoption of best practices in coding and application design. One key strategy is to rigorously check against expected values. For example, if a form field expects a number, the code should reject any text input immediately. Another essential practice is using um, parameterized queries or prepared statements. These techniques ensure the user's inputs are treated as data rather than executable codes. I have seen, projects where implementing these methods eliminate SQL injection risk entirely. Additionally, developers should minimize the use of dynamic SQL whenever possible. Regular code reviews and security audits are also very critical. These practices help identify vulnerabilities before they can be exploited. Uh, in in summary, prevention is a multi-layered approach that requires diligence and ongoing efforts. And now let's look at secure practices for coding. Secure coding practices are fundamental to defending against SQL injection. One effective approach is to use prepared statement with bound parameters. This method separates SQL code from data inputs, ensuring that malicious content is not executed. Um, Additionally, following a strict coding standard can help developers avoid common pitfalls. It is also important to sanitize and escape user inputs appropriately. For example, using functions to remove or neutralize harmful characters can mitigate risk. I recommend regular training sessions for developers to update them on the latest secure coding practices, and documenting and enforcing these standards across the organization is also very important. These measures create robust line of defense against potential attacks. And for database security measures, um, one key principle is the implementation of least privilege. This means that every database user should have only the minimum permission necessary to perform their tasks. Um, this ensures that known vulnerabilities are fixed in a timely manner. Encryption of sensitive data also adds another extra layer of security. Additionally, database firewalls can help monitor and block suspicious activities. I have seen cases where proper database configuration significantly reduce attacks amount numbers. These measures, when it's combined, form a comprehensive strategy to safeguard the data integrity. They also contribute to a culture of security within the organization. Web application firewalls, or WAFs, are an important tool in defending against SQL injection attacks. A WAF sits between the client and the server to monitor and filter incoming traffic. It can block malicious requests before they reach your application. For instance, if a request contains suspicious patterns, the WAF can deny it immediately. Um, However, it is also important to know that WAFs are not a silver bullet. They should be used in conjunction with secure coding practices and other security measures. Additionally, WAF requires regular update and fine tuning to remain effective. In some cases, misconfigured WAFs can actually lead to false positives and block legitimate traffic. Therefore, Continuous monitoring and adjustments are essential to maximize the effectiveness of WAFs. And regular security audits. They are essential for identifying vulnerabilities before they can be exploited. These audits include code reviews, penetration testing, the vulnerability assessments. I have observed that organizations that perform regular audits are far better prepared against SQL injection attacks. Um, Audits also help in uncovering weaknesses in both application codes and data configurations. For example, a periodic audit might review an outdated parameterization practice that needs to be updated. It is also important that to use automated tools such as SQL Map for consistent testing. Along with automated tools, manual reviews provide a human perspective to catch subtle issues. These audits also help in compliance with industry standards and regulations. And ultimately, regular security audits create a proactive security posture that minimize the risk and build trust with stakeholders. And now the conclusion of this presentation. SQL injection is a serious threat that requires our full attention. Um, in today's world, we have explore today and during this presentation, we explore the definition, the types, and real-world examples. Um, it is clear that prevention and early detection are key to um, mitigating these risks. The technique discussed are today are not just theoretical, but have been proven effective in real situations. I encourage you all to take these lessons back to your um, back to the class, back to school, and by doing so, you can help building a more secure digital future for everybody. And lastly, the recommendations. Um, so first one, I would recommend implementing strict input validations on all user supply data. Secondly, use parameterized queries and prepare statements to prepare codes from data. Third, ensure that your database user accounts follow the principle of least privilege. Fourth, invest in regular security audits and use these modern tools for vulnerability scanning. And fifth would be configuring web WAFs to provide additional layer of protection. So these recommendations are not only practical but also essential for maintaining a secure environment. I highly encourage you to evaluate your current systems and take the corrective actions as needed. And with that being said, thank you everyone for your attention, and thank you for listening. And that's the end of the presentation.